Welcome back, ladies and gentlemen. Today we're going to be taking a look at segments and their measures. Fun, exciting stuff. So our essential question for today, how do we measure distances between points in the geometric plane? So we're going to talk about basically a formula that could do that, distance formula. But to start off with some key vocab, in geometry, rules that are accepted without proof are called postulates or axioms. So we have theorems like the Pythagorean theorem that we know is true because it's been proven. But there's a lot of things in math that we can use, even though they're not proven true, hence these two names. The length of a segment is the distance between the endpoints. And when 3 points lie in a plane, you can say that one of them is between the other two, which should make sense. So postulate number one, ruler postulate, okay? The points on a line can be matched 1 to 1 with the real numbers. The real number that corresponds to a point is the coordinate of the point. All right, so if you're reading a ruler from left to right, all we're saying here is basically you can look at this. I know this is a clear ruler, okay? But if you had a point here and here, okay, if you want to find the distance from 4 to 2, you could just do 4 minus 2, right? That's all we're talking about here, okay? And that's what this is saying. The distance between point A and point B is written as AB is the absolute value of the difference between the coordinates of A and B. AB is also called the length of AB. These are absolute value bars. Absolute value by definition is the distance on the number line away from 0. In shorter terms, it makes things positive. Why is that important? We can't have a negative distance, all right? I always kind of relate this to driving a car. If you were to drive a car down the street 1 mile, right, your odometer will go up 1 mile. If you slam on the brakes, put it in reverse, and go backwards, please don't do that, by the way. Your odometer is still going up because distance is a positive value, right? So let's take a look here. Using the following diagram, find the distance between x and y. So here's, I'm going to write xy equals. Now I'm going to do the absolute value of 23 minus 7. Okay, so 23 minus 7 gives me 16. The absolute value of 16 is still 16. All right, now the reason I wanted to do that, and you don't have to write this down, but I want to share this with you. You could do 7 minus 23 and get the absolute value of negative 16. And those absolute value bars are there because it's going to make it a positive value. All right, so don't do it twice, but you get the idea, right? If you're reading a ruler, if you always take the further right number, subtract it from the further left number, you'll be in good shape. In the following diagram, find the distance from between M and N. So M and N equals, okay, so the absolute value of my farther right one is 19 minus my far left one. Now be careful here because it's negative 7. Now, a little blast from the past here. What does minus a negative become? Hopefully you guys are cool with that. Becomes a plus. So then that's going to be the absolute value of 26, which in turn is just 26. And you don't have to do it twice. Once is good enough. Okay. Cool. So simple enough. Reading a ruler. Need help with that? Say the word. All right. Segment addition postulate. This is a big one. Okay. It's also a very common sense one. Okay. So don't overthink this. If B is between A and C, then AB plus BC equals AC. If I've got two small pieces, all right, and you add them together, they're going to equal the big piece, all right? So it's just like taking two rulers. If I had one ruler held up with another ruler, that makes 2 feet, right? Okay, this is all it's talking about. No more, no less. It's that simple, all right? So it's just small piece. I always like to think small piece plus small piece equals big piece. Okay, cool. And you'll see what I mean on the next page. So we'll start off with a little bit of a tougher one, okay? But it's all good. We can handle this. Suppose J is between H and K. So if I was to draw a picture, I'm going to put J in the middle and HK on the outside. All right. Now use the segment addition postulate to solve for x, then find the length of each segment. They're telling us HJ is 2x plus 4. 2x plus 4 from here to here. Okay. Then they're telling us from J to K is 3x plus 3. I'm not kidding. I'm not just kidding about that either. Get it? Because J, okay. And then they want to tell us the entire thing is 22. small piece plus small piece equals big piece. So I'm going to do hj plus jk equals kh. All right. How does that look? Well, we're going to say 2x plus 4 plus 3x plus 3 equals 22. Combine like terms. 2x plus 3x is 5x. 4 plus 3 is 7. Okay. Subtract 7 from both sides. 5x equals 15. Divide by 5. X equals 3. So we solve for x. Great. But then it says find the length of each segment. Take this, plug back in. Okay. So up top here for hj, it says 2x plus 4. So 2 times 3 plus 4, which is 6 plus 4 is 10. And then the next one should be 12 because 10 plus 12 gives me 22. But just to double check, 3 times 3 plus 3, when you know it, we get 12. Okay. So that is a very good problem that you might see again. Okay. Just you get the idea. So good stuff. Number 4 in the diagram of collinear points, GK is 24. So the entire distance is 24. HJ, all right, from here to here is 10. And GH is equal to HI is equal to IJ. Now we're going to put little tick marks here. That just means that all 3 of these pieces have to be the same. Before I start jumping into all of these, okay, I'm going to solve each of these individually. So right here, if I know HJ is 10 and both of these pieces are the same, if I want to find one of these pieces, we could take 10 divided by 2. I know that that's got to be 5 and that's got to be 5. Well, that's cool. But even better off is that we know that GH has to be the same as these two. So this is 5 as well. Well, now we're on a roll. Okay, 5 plus 5 plus 5 is 15. The whole thing's 24. 24 minus 15, we get 9. Now we did a lot of work up front because now I can reap the benefits of it. HI is 5. IJ is 5. Okay, I have to box my answers off. GH is 5. JK, 9. IG, okay, from I to G all the way across. It's a 5 and a 5 if I add them together. 10. And then IK from I to K, 5 and 9, 14. Okay, so a little bit of work up front, then we're in good shape. Distance formula. This is a big one. This is a formula that will be provided for you, okay? So if A is the following point, x sub 1, y sub 1, and B is the following point, x sub 2, y sub 2, are points in a coordinate plane, then the distance between them is given by the following formula. Square root x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So all we're going to do is plug things into that formula. If you'd like, if you can look at the video, this notes online, there is an interactive example here of how this is done. I will tell you guys, those of you that are interested, I'm not going to get into crazy detail about it, but this is basically a variation of Pythagorean theorem. Okay, you know, a squared plus b squared equals c squared, because if I can draw this across and up, I form myself a right triangle. There's a neat little proof here. If you guys are interested, say the word, I will happily show you. Okay. So for number 5, plot each pair of points and find the distance between them. So A is negative 1, 0. There's my origin. So back 1. So there's my A, negative 1, 0. And then B is 2, negative 4. So to the right 2, down 4. So I'm trying to find this distance from A to B. Okay. Well, here's my distance formula. Right? X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. I'm going to make A x sub 1, y sub 1. I'm going to make B x sub 2, y sub 2. And we're going to plug everything right into this formula. What you see is what you get. So the distance of AB is equal to, now x sub 2 is 2. So I'm going to put 2 minus x sub 1 is negative 1. That's why parentheses are so helpful. Y sub 2 is negative 4. Minus y sub 1 is 0. All right. 2 minus negative 1 becomes 2 plus 1, which is going to be 3. Negative 4 minus 0 stays negative 4. Okay. 3 squared, 3 times 3 is positive 9. Ooh, this one though. Negative 4 squared. Negative 4 times negative 4 is positive 16. Okay, negative times negative. Add them together. Square root of 25. Square root of 25. 5. There we go. Distance formula. It's not always going to end up to a real nice number like that. Sometimes it might be a number under the square root, which is fine. We're going to talk about that. But there's a nice little intro to distance formula, which we will use a good bit because it is a very helpful formula. Okay. And again, you're not going to be asked to memorize that. You just have to know how to use it and apply it. All right. So guys, thanks for all your hard work. Keep up the good work. And as always, good luck. We're all counting on you.